Second, we have to design a digital Chebyshev filter given the question is 0.9 smaller and equal to Hej omega smaller than equal to 1. For 0 and equal to omega and smaller and equal to 0.25 pi, and for the same Hej omega smaller and equal to 0.2, and for 0.6 pi smaller and equal to omega n equal to pi, which t is given 1 second using bilinear transformation. So we can compare this equation and get ripple for pulse band is 0.9 and omega, which is the pulse band frequency, is 0.25 pi. Ripple for stop band is 0.2 and omega for stop band frequency is 0.6 pi. For step 1, draw the Hej omega, find frequency values, and we can draw the graph like this from the information we get. For frequency value, we can use formula cut-off frequency for pass band equal to 2 over T tangent omega p over 2, and we get 0.8284. And for stop band cut-off frequency, formula equals to 2 over T tangent omega s over 2, and we get 2.7528. For step 2, find and filter order, we will use this formula and substitute the value inside the formula and get n is greater than n equal to 1.6063. N is equal to 2.
I will present step 3 and step 4. For the step 3, the question asks us to find cut-off frequency omega c. For Chebyshev filter, omega c is equal to omega p, which is 0.8284. Next, step 4, find analog transfer function. To find analog transfer function, there are two methods, graphical method and also even or odd method. Here I use even or odd method to find Hs. For this function, is an even function because n is equal to 2. 2 is an even number. To use this formula, we need to find Vk, Ck, C0, Yn, and after that we can find Hs. For this function, n is equal to 2 and k is equal to 1. So here y2 is equal to 0.8044 by using this formula. After that, we can find v1 is equal to 1.1376. Next, c1 is equal to 1.1471. After that, c0 is equal to yn, which is 0.8044. We can use this formula and get capital V1 value, which is 1.0324. Then we substitute all the value that we find just now in this formula to find Hs. Lastly, we get Hs is equal to 0.7085 over s squared plus 0.9424s plus 0.7872.
I will continue for the step 5, find digital transfer function. So from the step 4, we already got the Hs. So for this one, we substitute the S value into the Hs and got this one and expand and simplify it until we got this one, this form. So we move to the step 6, draw block diagram of IIR using direct form 2. So this left hand side, we took from the poles here, denominator, and the right hand side we took from the numerator, which is 0. So for the first line, 1 for the poles and 0.1062 for the zeros. And we go to the second line, here have the delay, and for the poles we have 0.9630. Positive because poles is negative and this one already got negative, so becomes positive. And for this one is 0.2124, And we go to the third line, have the delay z -1, because here is z -2. So for the poles, we have negative 0.4350. We put negative since it's poles, and for the zero, we have 0.1062. So that's all from our group. Thank you.